Welcome to This Explainer. Okay, let's just dive straight into this. Today, we are mastering one of the most critical, absolutely unskippable topics across the Cambridge mathematics syllabuses. Whether you are tackling IGCSE Additional Mathematics 0606, Standard Mathematics 0580, or looking at the O-level variants like 4024, 4037, or even jumping into 4040, we are talking about geometric progressions. Specifically, we're looking at using the formulas for the nth term and the sum of the first n terms. Now, if you've been grinding through past papers, you already know this topic appears in absolutely every single examination series. You literally cannot escape it. And honestly, you shouldn't want to, because it is an absolute goldmine for marks if you just play the game right. But here is the major challenge. Picture a dynamic split screen in your mind right now. The clock is ticking down, tension is high. On one side, we have a student named Alex. Now, Alex is smart. He has memorized every single textbook definition. But in the exam hall, under pressure, he overloads his answers with raw mathematical facts and absolutely zero logical analysis. The examiner's red pen just slashes right through his working. Ouch. On the other side, we have Sam. Sam is fast, really fast, but he rushes, and he completely misses the crucial command word requirements hiding in the question. Both of these students are dropping whole grades because their answers have loose threads. So today, we are going to act like master tailors. We are going to ensure you tailor your answer to fit the question perfectly. No loose threads, no wasted effort, just maximum marks. Let's look at exactly how to get there. So what exactly goes wrong here? Why do smart students consistently lose easy marks on geometric progressions? Well, we call this the method mark challenge. You see, Cambridge isn't just testing if you can somehow arrive at a final number. They are testing your multi-stage analysis. You might be sitting there right now thinking, but wait, the formulas are literally given to me in the exam booklet. How on earth can I lose marks? Well, my friend, that is exactly the trap. Because those formulas are provided, examiners are actually hunting for your method marks. They want to see the sequence of your logic. When you look at Alex's script, for example, he jumps from the raw data straight to a final answer using his calculator, completely skipping the structural breakdown. And because of that, he loses the M marks, the method marks. And here's the harsh reality. When you lose method marks, a tiny typo in your final calculation means you get a 0 for a 5-mark question. No partial credit, nothing. Top-tier candidates know that the final answer is really only the tip of the iceberg. The method is the actual iceberg. Let's think about the exact geometric progression formulas provided in the Cambridge examination list of formulas. You've got the nth term, and you've got the sum of the first n terms. You need to ground yourself in this one undeniable fact. Since Cambridge hands you these mathematical tools on a silver platter, they are fundamentally not testing your memory. They don't care if you can memorize a formula they already gave you. They are testing your application and your process. Can you actually identify the first term A? Can you flawlessly extract the common ratio R from a really dense, complex word problem? Can you distinguish when a question is asking for the 10th term versus the sum of the first 10 terms? I know, it sounds super basic right now, but under immense exam pressure, Sam constantly mixes these up because he rushes past the command words. The examiners are watching your procedural execution like a hawk. Remember, a tool is only as good as the person wielding it. If you don't show them how you use the tool, you don't get the points. Let's move into Section 1, Core Geometric Principles. This is the underlying theoretical foundation that definitively separates the perfectly fine average answers from those top-tier A-star exam scripts. Top students approach these core principles by decoding the command words first, and they do this using the PEEL framework: point, evidence, explanation, link. In math, this translates directly to state your principle, show your evidence from the given data, execute the mathematical explanation, and finally, link it back to the specific context of the question. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, back to the strategy. As the syllabus guidelines highlight, top-performing students exhibit connected, conceptual understanding that is fully transferable to unfamiliar contexts. But what does that actually mean for you sitting in the exam hall? It means just memorizing the formula isn't going to cut it. You might suddenly get a question about a bouncing ball, or a depreciating company asset, or even a viral population growth. If your understanding is purely mechanical, you'll freeze up. But if your conceptual understanding is connected, you immediately recognize, this depreciation is just a geometric progression where my common ratio is less than 1. It's that logical, structured reasoning and analytical depth that examiners prioritize way over superficial breadth. Let's break down this theoretical architecture a bit more. Notice the 3 pillars holding up these top-tier answers? precise definitions, causal relationships, and cross-topic integration. And that last one is huge. Principal examiner reports specifically show that candidates who actively reference cross-topic connections achieve significantly higher marks. For example, you might be asked to find the value of n for which the sum of the progression exceeds a certain number. Suddenly, without warning, your standard geometric progression question has magically transformed into an inequalities and logarithms question. You absolutely have to use logs to bring down that n from the exponent. If you just treat geometric progressions as an isolated island that has nothing to do with the rest of the syllabus, you are going to sink. You must build bridges. You must understand the causal relationship between the common ratio and the behavior of the sequence. Like if r is negative, you know the terms are going to oscillate. Positive, negative, positive, negative. If you know this underlying architecture, you are practically bulletproof going into the paper.
Moving right along to Section 2, Standard Procedural Sequence. We've talked theory, now it's time to build a solid visual architecture for your answers.
To permanently turn those red pen marks into gorgeous green check marks, we need to implement the mathematics success blueprint. When you step into that exam hall, you shouldn't be relying on a sudden burst of inspiration. You should be relying on a rock-solid standardized procedure. And here is that exact system, the method mark strategy. Step 1, identify key elements. Explicitly extract A and R and write them down. Step 2, apply relevant principles. Look at the formula sheet and choose the exact right formula. Step 3, execute analysis. This means incredibly clear line-by-line algebraic working, no skipping steps. Step 4, verify results. Take a breath and ask, does this answer actually make sense in reality? Let's give Alex and Sam a 60-second visual timer to rewrite their previous disastrous answers using this blueprint. Watch what happens. Alex stops brain dumping and writes out step 1 explicitly. A equals 5, R equals 2. Boom, method mark perfectly secured. Sam finally slows down, reads the command word carefully, and realizes he needs step 4 to verify if a negative term number makes sense for his sequence. It doesn't. He catches his own mistake. Marks are awarded for this exact systematic processing. And I really want you to notice how this practical application absolutely demands correct formats, clear notation, and appropriate terminology. This is what we call professional-level execution. You are extracting messy data from texts and tables, and you have an obligation to translate it into pure, unassailable mathematics. If you use sloppy notation, if your R kind of looks like an N because you're writing too fast, or if you accidentally drop a negative sign during your formatting, the entire logical chain breaks down instantly. The examiner physically can't give you the execution marks if your notation is ambiguous. They aren't mind readers. You have to communicate mathematically like a true professional. All right, Section 3, Top 3 Examiner Warnings. We're shifting gears to some high-stakes pitfalls pulled straight from the highly confidential Cambridge Principal Examiner reports. Listen closely. Before we reveal the first massive mistake, let's do a 60-second data scan challenge. Imagine a really complex math table on your screen. It's showing a company's profits doubling every single year, but there's a weird flat tax deduction thrown in at the end. Your brain needs to instantly scan that data and extract the core trend. It's a geometric progression modified by a constant. If you can't scan that data and extract the mathematical model, you are dead in the water before you even pick up your pen. So what is warning number 1? Forgetting proper format. Examiners report year after year that students lose ridiculously easy method marks simply by failing to format their equations properly. Let's do a find the flaw challenge right now. Imagine reading a sample paragraph from a student. The sequence goes 3, 9, 27. So I used the formula and got 59,049. What is the critical flaw here? The flaw is that the student never explicitly stated the format. They never wrote down the nth term formula. They never explicitly wrote out that A equals 3 and R equals 3. If that final answer is wrong due to a silly calculator typo, they get absolutely 0. Always write out the formal equation first. Format is your safety net. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Okay, moving to warning number 2, ignoring presentation checks. And this builds directly on the point we just made. Failing to review your format and presentation before you move on completely sabotages your final score. I've literally seen top-tier, brilliant students lose an A-star grade because they wrote their exponents so sloppily that a power of n-1 suddenly drifted down and looked like it was being multiplied by n-1 on the very next line of their working. Their own messy presentation led their own brain astray. Or, another classic, they forget to use brackets when dealing with a negative common ratio, so their calculator spits out the wrong sign. Your presentation is your direct line of communication with the examiner. If your page is a mess, the examiner naturally assumes your thought process is a mess. Take the extra 2 seconds to visually check your algebra before you confidently press equals on the calculator. Now we are exposing the ultimate pitfall right here. Warning number 3, providing generic answers. This is the absolute classic mistake constantly highlighted in examiner reports. You deliver an answer that is not specific to the actual context given in the examination scenario. Let's do a quick 30-second speed writing challenge in our heads. Write a peel paragraph for this. The question asks why a geometric model might not be appropriate for predicting a real-world population of rabbits over 100 years. If you just quickly write, because geometric progressions go to infinity, that's a completely generic answer. It gets 0 marks. Why? Because you haven't engaged with the context at all. You need to seamlessly adapt your mathematical knowledge to the specific, messy reality of the question they gave you. Let's visually contrast these two approaches to really hammer this home. The generic answer states the sum goes to infinity. Simple, true and pure math, but useless here. But look at the context-specific answer. It says, the population of rabbits cannot grow indefinitely according to this geometric model because environmental resources such as food and space are limited, causing the common ratio to eventually decrease. Do you see the massive difference there? The context-specific answer proves to the examiner that you understand what the mathematics actually represents in the real world. You must tailor your answer perfectly to the question's context to avoid losing those evaluation marks. No loose threads. The examiner desperately wants to see that you're not just a programmed human calculator, but a deep analytical thinker who understands the real-world application of the formula. Welcome to Section 4, Deconstruct, Solve, Evaluate Strategy. This is the ultimate framework required for conquering the higher-order assessment objectives in additional mathematics. This brings us to the beating heart of our system, the problem-solving triad. If you've been relying purely on instinct up until now, this is where you build an absolutely unbreakable system. Step 1, deconstruct the given information. This means breaking that dense paragraph down. Is it asking for an exact value? Is it asking for an approximation? Step 2, solve systematically in logical steps. This is your core algebra, clearly spaced out, showing absolutely every single substitution into the geometric progression formulas. Step 3, evaluate for reasonableness. And let me tell you, this is the step almost everyone skips. If you calculate the sum of the first 10 terms of a decreasing geometric progression, and your final answer is somehow larger than the sum to infinity, your answer is mathematically unreasonable. You've definitely made a mistake. This triad forces you to justify your decisions, catch your own errors in real time, and secure absolutely every available mark on the paper. When we look closely at evaluative thinking mastery, it becomes incredibly clear that top-scoring candidates don't just blindly calculate, they evaluate everything. When the question asks you to question assumptions, you must consider different perspectives. When you draw conclusions, you must use comparative connectives. For example, instead of just stating 2 numbers, say, the sum of the geometric progression is greater than the arithmetic progression initially. However, as n approaches 20, the trend reverses. You are actively comparing approaches and evaluating alternatives with hard mathematical evidence. If the question asks you to justify decisions, you must provide evidence-based recommendations relying directly on the specific values you calculated using the nth term formula. You are definitively proving to the examiner that you are a master of the syllabus, fully capable of descriptive, analytical, and evaluative thinking. This is exactly how you guarantee that A-star. So the final provocative question I have for you today is this. Are you ready to apply this blueprint to your very next past paper? We've successfully decoded the command words, we've applied the systematic peel frameworks, and we've exposed the top examiner traps that catch thousands of students every year. The next time you face a grueling past paper, who are you going to be? Will you be Alex, desperately overloading the page with raw facts and bleeding all those easy method marks? Or will you be the master Taylor, crafting an incredibly analytical, beautifully contextualized answer with absolutely no loose threads? The choice is entirely yours. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.